Good morning, everyone, and welcome to SNK America. Thank you for spending the morning with us here. We're going to start a presentation here. I'm going to be talking here for the next little bit about the application of five-phase machining technology, so we can understand, where to apply it, why it matters, and what benefit it has to the customer. Feel free to stop and ask questions along the way. This is an open forum, so if you have a particular question about anything we talk about here, feel free to ask and I'll answer as best I can. A typical machining landscape, we call it, for parts that would be applicable for five-phase consideration are, a lot of parts require machining on not just one surface but multiple work surfaces, as you see in this illustration here. What happens is when you do this, you have to have what we call multiple setups to reach all these attributes and machine the part to your requirements. Every time we do this, we create certain conditions that are maybe not so desirable for the part accuracy, the performance of the machine, efficiency. Some of these we're going to talk about today in a little more detail are lost productivity, inaccuracies, or stack up of tolerances, and also safety concerns that may be associated with moving a large part around. Traditionally, we're going to get much more into this, is that parts of this nature, especially the bigger they get, that require machining on multiple faces or planes, one of the more common traditional solutions have been horizontal boring mills. Here you see a couple illustrations of it. One being the horizontal boring mill on the left, and the other being we call a large C-frame style vertical machining center on the right. If we go to the right-hand illustration of the C-frame machine, you can see it here without the covers on. It's basically a fixed column with a spindle that's overhung to reach the table in the y-axis. There's some limitations on this type of solution, and we'll talk a little bit more about that coming up here. What a lot of customers will do is take a machine like this and put a rotary table setup on it to create that ability to move the part around instead of flipping it. The advantage of this to the customer mind is that one is that it's a solution they already have in-house. They can make it work somehow. And it's also very familiar to them as far as putting a part on a vertical machining center. So it's a very easy transition for them to make. Not always the most efficient, but it's a way to make a part. A more common thing that we see, because we deal with much larger parts here at SNK, is that we see a lot of people using horizontal boring mills to do this type of work on. There's many ways that people do this. The boring mill is probably a better solution than a C-frame vertical for most instances. However, it still has its limitations. Some of the benefits of using a horizontal boring mill with a quill is that you get access to four sides of a part typically. Most of these machines have rotary tables on them where you can spin the part to 4 different work planes or 360 degrees depending on the configuration. The other things that these machines traditionally have is a very large work zone. So they're generally uncovered machines without enclosures. You could put very long parts on them. They have extended x-axis travel and y-axis capabilities, so you're able to put a very large part on these machines, and that's a benefit to a customer. The other thing they have is these machines come with what we call a quill or a w-axis or a feed-out type axis. What this does is it expands the capability of the process to be able to reach into a part. So these are all benefits to using a boring mill, and this is actually a better solution for making these large 5-sided parts than a C-frame type machine. However, not without limitations. Speaking of limitations, just recapping a little bit as we get into more detail on these, the 3 primary considerations in our world anyway are accuracy of the parts. We're going to talk more about that. The efficiency, which is key in my mind to why you would apply a 5-phase type solution. And then also safety. That's a big factor. As more and more, every day we see more and more customers who are really focused on the safety aspect of their operations, keeping their operator and personnel safe, The first point was accuracy. You talked about, this is an illustration showing a typical boring mill type solution. You can see the tool at the top of a y-axis. This is a large machine that has a lot of range in the y and x-axis. There's a couple issues with doing this, depending on the part and the application. The farther you move up the column, you start to get deflection. So what happens in deflection? It affects accuracy, and it also affects rigidity and the ability to cut heavy. So the column will start to push back. The harder you push on the part, the workpiece setup, the farther you are off the table, you start losing cutting capability and also accuracy. That being said, the other part of that, if you're high up on the y-axis column, you're also high up on the part stack up, fixture, or whatever the case may be. So you're also going to see not only deflection in the column side on the machine side, you're going to see potential deflection on your workpiece setup. So that's just a multiple of deflection and loss of cutting capability that you get when you're high up on the y-axis. The other thing that happens on a horizontal boring mill is that it's nice to have the capability to push your quill out to get extended reach. What happens when you do that, however, is you start to lose cutting capability the farther the spindle extends out. And this is true on every single boring mill ever made. Anything with a quill, the farther you are extended, you start to get two things happen. One is that you lose cutting capability. So the cutting capability starts to go down the farther you get extended. So you can't cut as heavy. Maybe you got to use a smaller tool. You got to take more passes. You got to baby the process a little bit more. The other thing that happens is that when the quill gets extended, there's what we call droop that happens. So every spindle droops. It's just how much does it droop? And does the droop that you get at full extension or wherever you are in the stroke, does it still allow you to make a good part? That's the question that the customer has to ask. Some cases, yes. Some cases, no. So customers that want to use this type of solution to make a large part and move it around through its setups have to consider these things. And the other thing that we're going to talk about a lot, you'll hear me say this many times throughout this presentation, is lost accuracy. This is a big deal. You know, especially the tighter your accuracies are between your features on different work planes, this is key to a five-phase application. There's several keys. This is one of them, is that the less number of setups you make on a part, the more accuracy you're going to get between features that are machined on those planes. And the third component we talked about was safety. I'm going to throw housekeeping in there as well. Safety / housekeeping. You can see the picture here is an illustration of a large steel plate strapped up on a boring mill on probably a right angle plate. It doesn't show the actual process of loading it, but you can imagine what someone would have to do to put a part up on a machine like that. So typically what will happen is you'll see a couple guys, one guy operating a crane, and it'll be hoisting the part up via crane. There'll be a couple guys probably standing on the machine table trying to clamp this part into place. All the while, this large part piece weighing thousands of pounds potentially or more is fighting gravity to try to stay in its position so you can clamp it onto the locators. This is certainly not the safest way to load a part onto a machine. The unclamped workpiece is a safety concern, obviously. You have it suspended from a crane. You're relying on the crane itself and some operators to make sure it gets secured safely and efficiently. There's been some bad stuff happen. I've seen some stuff personally in shops that I've been in that I cringe when I see it. I'm like, I don't want to know about it because it's kind of scary. And I think that in today's market, you're seeing more and more people get away from those unsafe type operating conditions. And a five-phase, a vertical machining center, like we're going to talk about here in a little bit, is a really good solution if the application is right. The other thing is, point number 3, is an exposed and machining environment. These machines are typically either come without enclosures on them, or sometimes they have like a table guarding on them. The table guarding is nice for containing some chips, but it's also very restrictive when you're making a big part. A lot of guys will pull those table guards off because the part is too long to put in there, and they'll try to utilize more of the x-axis. So what happens is now you have an operator who is going to be for lack of a better term, in harm's way of chips and coolant, and he's going to be put at risk from a safety standpoint. So a lot of people are also tending away from this type of solution for those reasons. Talking about efficiency, this is a big one for five-phase machining. This is really where we talk to customers about the potential for a ROI or a justification or to improve their deliverables to their customers. This is all very key to the application on a five-sided machine. You know, lengthy setups. Typically when you got to move a part, in our case, larger parts, through multiple setups, it takes time. So time is money in our industry, right? You want to make your parts as quickly as you can with a high degree of accuracy. There's also, on like a boring mill, for example, a guy wants to do five-sided machining on a boring mill, he'll maybe buy an attachment from the builder or a third-party attachment. These attachments are almost always manually attached to the spindle. We see this, people doing this all the time. We have customers that do it as well. It's a lengthy process to manually pull an attachment on and off a spindle. It can take up to an hour in some cases just to put the attachment on and off. So you're cutting into your efficiency of the process. Lower chip removal rates near the travel limits. We talked a little bit about when the y-axis or the quill is extended out to full extension, also at the top of the y-axis, you start losing cutting capability. Not only does it take more time because maybe you got to take a smaller cutter or more passes, but it also can affect cutter tool life because you have less cutting rigidity there. So there's a lot of things associated with the reduction in cutting capability at the extremes of the travels. Also poor chip management. We just talked about it. You know, typically open machines, the operator's at risk being hit by chips, coolant, other contaminants. In addition to that, the coolant and the chips that are hitting the operator potentially are also getting all over the shop floor, creating slip hazards and other things. So it's important to consider all this stuff when looking at these types of solutions. The CFrame solution. A lot of guys do this because most people have a CFrame machine in-house. They try to find a way to make it work to get their job done. And after they get the job up and running on a CFrame, maybe as a temporary solution, they just live with it because it's a known and they can make their part, but they're not doing it efficiently. What they do is, we talked a little bit earlier, they'll try to apply a rotary table setup on a vertical so to create like a five-phase machining environment. That's all fine, but what happens is that table takes up a lot of the z-axis stroke. So you start losing stroke, so you gotta look at that pretty carefully. Now you have a long tool requirement and you've lost, 15 inches of your z-axis stroke, you may not be able to make your part. They also typically have very limited range in the y-axis. So if you have a part that requires a large y-axis or is wide, a C-frame machine might not be a good solution for it. Typically, if you get over about 30 inches or so on a C-frame machine, that's getting pretty large, and that creates other issues as well. Which is point number 3 here. When you get to a very large extended y-axis on a C-frame type machine, you start losing rigidity again because you have a large overhang of the spindle from the column center. So these are some of the things to consider when you're looking at doing large five-sided machining parts on traditional type solutions. It's the definition of five-phase machining, or five-sided machining as we call it sometimes. Five-phase machining for us is the use of automatic attachment and tool changing capabilities on a large capacity machining center. It provides cutter access to features on 5 or more faces of a workpiece in a single setup. So now in this illustration you see we're going to be able to take the tool and move it around the part, all the way around the part index, in our case 1 degree. Some people have 5-degree couplers or 90 degrees. But the point is that you'll be able to take a single setup and move your tool around the part to access multiple work planes. What's the benefit to the end user? The benefit is that now you can have a single setup and you can move your tool around the part and gain cutter accessibility to features that you might not be able to reach in a vertical or a boring mill single approach type application. So what we're doing here is we're creating increased accuracy of the part. You're being able to deliver your parts to your customers faster because you're not having a lot of downtime on your spindle as you're flipping or moving the part around. So overall, you're improving your efficiency of your process. Accuracy. We're going to talk a little bit about the attributes of what we provide here is double column style 5-phase machining centers. Which, by the way, there's one on our floor out here you can see here when we're done, and there's going to be some demos run on it illustrating all this. Since we're a double column and we have a cross rail here, the first 2 points is we don't have to worry about losing cutting capabilities when we extend out, because now we can position the tool with a very short projection as close to the workpiece features as possible. How we do that is we have there's no column deflection because we have the double columns, and we can move the rail to the parts. The rail is the W axis, is a cross rail. In our case, our cross rails are fully programmable. There's many styles of machines out there, bridge type machines or double columns. Some have fixed rails, some have movable cross rails, positioning. We use a fully programmable cross rail. So what that allows us to do is by moving the cross rail and the quill together, we're able to position in a manner which keeps the quill extensions and the tool extensions as short as possible by increasing cutting capability, the ability to take heavy cuts, to remove material very efficiently. And then the big one that everybody focuses on is this one here, is the accuracy between setups. What we get is that we have we call a one and done type operation. So the part goes down on the table one time, you clamp it down, and you machine 5 or more faces of the part in a single setup. That's going to create the most accuracy of any type of process you can use, because you're not influencing the part with multiple work clamping, so locator to locator surface, or inducing forces, unnatural forces by clamping with different pressures and different attitudes. And we have no deflection from the overhang on a CFrame style machine. Again, for the same reasons, is that we have our cross rail we can position right to the part. Safety. Here's an illustration of what we were talking about earlier, is putting a part up on the left-hand illustration on, say, an angle plate on a big horizontal boring mill type application. You see how tall the workpiece is? Somebody or multiple guys got to be able to load that, not only load it up there and put it against the plate, someone's got to clamp it to make sure it's securely fastened. There's a more natural way to do that on a vertical machining center like ours, is to put it down onto the table flat, in essence allowing gravity to help the clamping process versus fighting gravity when you're trying to clamp something horizontally onto a plate. This point here becomes magnified the bigger and heavier the workpieces get. The bigger the workpiece gets, the more this becomes a huge advantage for the solution that we provide. There's a couple illustrations of our 5-sided machine with the attachment changer. What we can do is that you see here, this is the automatic storage device for the attachment changer. We have a right angle attachment on that we can load or unload to this device automatically. The operator doesn't have to do anything other than push a button and have the program call it up. So it'll load and unload that. When this is unloaded, we can put a Cat 50 tool right in the bottom of the quill and drive it like a vertical machining center. When we put this on, we can take this over to the automatic tool changer and it'll automatically change the tool in the right angle attachment itself. So we can load and unload the attachment automatically, and we can load and unload tools into the attachment or the vertical spindle automatically. You can see here we call this done in one, or one and done, whichever you prefer. One setup, the part is complete. One other note on here I want to point out, simplified fixturing. The other thing that putting the part down onto a large part down onto a double column machine versus a horizontal boring mill, it allows us to dramatically simplify the workpiece clamping. If you're trying to hold a part up onto a fixture plate on a right angle plate or a tower on a horizontal boring mill, you have to have obviously more clamping, potentially stronger clamps. It's a longer process and the fixturing can become more complex to do that. This is an easy way. Put the part down, let the weight of the part itself help seat it on the locators, and do some simple clamping. Efficiency. Spindle utilization is the key. This is the reason why most people are looking for us to come in and look at their process and figure out if the 5-sided machine is the right solution for them. They want to get better spindle utilization. And this is true on any machine in any shop. A turning center, a horizontal machining center, a boring mill. It's always about spindle utilization. How much of the available spindle time is being used to make chips? You run 20 hours a day. How much of that time is actually making chips versus non-cutting time or setup time? When you look at this, a traditional boring mill is less than 50% spindle utilization. On a 5-phase machining center, typically there's 70% or greater efficiency or spindle utilization. That's about a 40% difference in efficiency and spindle utilization, so chip making time basically. I think for almost any company that would have a huge impact to be able to increase your spindle utilization by 40%. What happens when we increase our spindle utilization? We become more productive. We can get more done in less time. We also get more competitive against our competitors. You get better, you can deliver faster, you can make more accurate parts, you can probably reduce your price to the end user and be much more competitive in the marketplace. Also create more profitability for you, the end user, because that's what it's all about. You know, you're in business to make money, right? I'm going to talk a little bit about our particular solution that we have for 5-sided machining. And just to make a point is that this is one platform for 5-sided machining. There's many types of 5-sided machinings out there. We have another machine out there that's a CMV 100 machine. That also could be used as a 5-sided type machine in addition to 5-axis. People make small verticals, trunnion machines. These are all potential 5-sided machines. We're talking about this today because we're focusing on our machine we're displaying out here for large part solutions. We talked earlier, this machine has a cross rail that's fully programmable. So we can actually, by NC command, move the cross rail anywhere in the work zone. So what that allows us to do, like we talked earlier, is that if the workpiece surface is up here, we can move that rail right just above that surface and keep our quill extension and tool extensions as short as possible. We can do various attachments, which I'm going to show you in an upcoming slide here. These are some of the common attachments that we have on the machine. Our machines all come standard with a 3-position attachment changing device, like you'll see in the showroom out here, or tech center. When you're using a vertical spindle, there's this thin dust cover on. This is basically to protect the clamping mechanism for the right angle head. And the tool goes right into the Cat 50 spindle. You use it just like a vertical machining center. It's no different. It's exactly the same. We can also provide, our machines all come standard with this right angle attachment. This attachment gets loaded automatically like we talked about, and it's capable to do some heavy milling, drilling, tapping, any operation you would normally do in a 3-axis mill or a horizontal boring mill, you can do with this attachment as well. And then we have also available other attachments from our factories. One of the more common ones is called a universal attachment. This allows us to turn basically, other than just the 360 around here on our 1 degree, we can actually make compound angles with this. So if your workpiece has compound work planes, we can accommodate it with this attachment. In addition to these more, I would say, traditional attachments, SNK has a library they've built over time of hundreds, if not thousands, of special application attachments. So we can accommodate just about any application that you have. Here's a small sampling of some of the more common ones that we see in industry. Again, the right angle attachment, universal attachment, an extension attachment to get a little bit more reach as needed, a fixed angle ones. A lot of guys in die mold use this type of solution. To conclude this presentation this morning, just to go through a couple more of these facts here we've been talking about. horizontal boring mills and C-frame vertical machining centers have been kind of industry standard type solutions for guys to make parts in either multiple setups or try to apply some type of 5-phase solution by adding rotary tables to them, with great limitations in many cases. These limitations have caused machine tool builders to look for a new technology to make these parts, especially as they get larger and larger. SNK has been one of the pioneers in coming up with large 5-phase machining solutions like our RB style machine you see in the tech center.